Now let's take a look at 1.2, which talks about, we are going to learn about mixing juice, which is all about comparing ratios. So first, let's go ahead and understand the story by reading this paragraph together. These paragraphs. So every year, the 7th grade students at Langston Hughes School go on an outdoor education camping trip. During the week-long trip, the students study nature and participate in recreational activities. Everyone pitches in to help with the cooking and cleanup. This year, Arvin and Mariah were in charge of making orange juice for the campers. They planned to make the juice by mixing water and frozen orange juice concentrate. To find the mix that would taste the best, they decided to test some mixes. So here are the mixes that they tested. So they have A, B, C, and D. And with each mix, they use different amounts of concentrate to water. Now you have to remember, the most important thing to remember on this, like for example for mix A, if there's 2 cups of concentrate and 3 cups of cold water, that yields 5 cups total. All right, so you have to remember that. So there's 3 values for each one. There's how much concentrate, how much water, and then how much total. So keep that in mind as you answer these questions. So part A, number 1 and 2, they ask number 1, which mix will make the juice most orangey, and explain your reasoning. And 2, which will make it the least orangey, explain your reasoning. So go ahead and do numbers 1 and 2 on part A, and then come back to the video so we can talk about it. So on number 1, you should have mix A is going to be the most orangey. Because if you look and compare the amount of concentrate to total fluids. So I have the numbers to the right here that you can look at. So 2 to 5, 5 to 14, 1 to 3, 3 to 8. And 2 to 5, that is exactly 40%, and all of the other ones are less than 40%. So this is the highest concentrated mix. Then if you look at number 2, which asks which mix will make the juice the least orangey, looking at this, questions like this might be a little bit easier to look at if we have the percentages. So on all of these, I made the percentages, just took the top divided by the bottom, and you notice 40% is the biggest right here, and then the smallest is going to be mix C, which is at 33.3%. So the least orangey one is going to be C, and then we can use all of or any of what I've said or put down here as our explanation. Let's go ahead and take a look at B. Number 1, Isabel and Doug use fractions to express their reasoning. Do you agree with them? So Isabel says 5/9 of mix B is concentrate, and Doug says 5/14 of mix B is concentrate. Who do you agree with? Go ahead and answer this, and also part 2 on B. Answer those, and then come back to the video so we can discuss it. All right, on the first one, we've kind of already answered this because on part B, we had our ratio right here that was already 5 to 14. And so that is our ratio from mix to total. So you would say that that's 5/14 concentrate. You would not say that it's 5/9. Right? Because that's concentrate to water, but in order to tell how concentrated something is, it needs to be the amount of concentrate to the total amount of fluids or liquids in that container. So in this case, Doug is correct. And make sure in your notes you're able to explain why Doug is correct. And the reason is because Doug compared the part concentrate to the whole, where Isabel compared the part concentrate to the part water. And in order to really get an idea of what percentage or how much concentrate is in something, you need to compare the part to the whole. And then in 2, if you haven't done that one, make sure you pause the video and do number 2 as well. But on number 2, it says Max thinks mix A and mix C are the same because Max says they are both the most orangey since the difference between the number of cups of water and the number of cups of concentrate is 1. Is Max thinking correct? And so let's look at what Max is saying. So Max is saying on mix A, you have 2 cups of concentrate, 3 cups of water. And on mix C, you have 1 cup of concentrate and 2 cups of water. So what Max is saying is, hey, listen, if I take 1 cup away from each of those, I would get 1 cup of concentrate and 2 cups of water. Therefore, these are the same because I'm just taking 1 cup away from each of those. Max is incorrect. 2/3 and 1/2 are not actually equivalent. They're not the same because they are not equivalent fractions. So if you take 1 cup of concentrate and 1 cup of water, it will not yield similar results. Okay, so if you want to yield similar results, so if you have 2 to 3, you can multiply each one by, like half. So that would give you 1 to 1.5. Those would be the same, but you cannot add or subtract cups to it. You have to multiply by a factor or a scale factor. So no, Max is not correct on number 2. Let's take a look at C. On C, assume that each camper will get 1/2 cup of juice. Answer the questions 1 and 2 below for each of the 4 recipes. So you're going to answer for recipe A, B, C, and D for each one. So part 1 says how many batches are needed for 240 and how much juice concentrate and how much water are needed to make juice for 240. So you're answering both of those for each mix A and B and C and D. So go ahead and do part C, numbers 1 and 2, and then come back to the video to see how you did. Okay, so hopefully you tried this on your own. If you need a little bit of help, this is kind of how I set up. Mix A through D. First of all, figure out if I create mix A, how many cups total will that yield? If I create mix B, how many cups total will that yield? And I have those here. Right, and I got those by adding the amounts of concentrate to the cold water that you're going to put in there, and that's how many cups total. Right, so mix B obviously will give us the most cups, will yield the most cups. So now number 1 says how many batches are needed for 240 campers if each camper will get 1/2 cup of juice. So one batch for mix A, which is 5 cups, that will feed 10 kids. If each kid can have 1/2 cup. So if one batch can feed 10 kids, we are going to need 24 batches. Right, because we need to feed 240 kids. So if one batch can feed 10, 24 batches are going to be made so we can feed all 240 kids. So if you haven't done this, go ahead and do this for mix B, C, and D, and then come back to the video. Okay, so check your answers with mine, see how you did. Now again, I get this number right here, the 24 batches, because the math behind that is if you know that you need 240, there are 240 kids, and one batch feeds 10 kids. That's where I need the 24 batches. That's where that comes from. All right, so you would do the same thing for all of these. For mix B, if it feeds 28, so you would take 240 over 28, and that gives us 9, and so forth for each one of those. So go ahead and check how many batches for each you would need. So that answers part 1. And then part 2, how much concentrate and how much water are needed to make juice for 240 campers. So if you haven't answered that question, go ahead and pause the video and try on your own to answer that question. Okay, so let's take a look at each of these. So if we take the original recipe, like right here's the original recipe for each one. Concentrate 2 cups of water. And now to find if we need to make 24 batches, we're taking the concentrate and the water and multiplying by 24. And so for the first one, you would need 48 cups of concentrate, 72 cups of water. So this is concentrate to water. Okay, and then for the second one, you would need 45 cups to 81 cups of water, 40 cups of concentrate to 80 cups of water, 45 cups of concentrate to 75 cups of water. So if you are planning this for all of these campers, you know how much water you would need and how much concentrate you would need to get from the store so that every single camper can have 1/2 cup of orange juice. That's a lot to feed 240 kids. So now let's take a look at part D, which reads, for each recipe, how much concentrate is needed for 1 cup of juice? So if you wanted just to feed one person, obviously you wouldn't want to do this, but let's say you did, how much concentrate and how much water would you need for one student or one camper? So to answer this, you would need to come back here using the original, like 2 cups to 3 cups, but we only want to yield 1 cup total for each one. Go ahead and answer part D and then come back to the video to see how you did. So on this one, it's kind of tricky. So let's see. You might need some extra help. So let's look at mix A. Right, so mix A, first of all, is 2 cups of concentrate to 3 cups of water, yielding 5 cups total. So the tricky part is getting this same recipe to be in one single cup, right? And here's how you do this. So first of all, in order to keep the concentrate to water the same, well, we know that there's 5 total. So what we're going to do is we're going to split the top so that it's 2/5 concentrate, and then the water is going to be 3/5 water. Now the reason is because you know that the original is out of 5 total, so that's why we're going to split these so they're both out of 5, right? But we create them ratio over each other, so it's 2/5 over 3/5, and that will yield 1 cup of juice. Okay, so this yields 1 cup of juice. This is the easiest way. There's other ways probably to think about this, but go ahead and use the same strategy for mix B, C, and D if you haven't already. So if we look at each mix, the ratio of concentrate to water, that's what this is. Then the total amount, okay, we can follow the same pattern as we did for mix A. So for mix B, right, it's going to be 5/14 concentrates to 5/9 water, and that will yield 1 cup of juice. And the next one is going to be 1/3 concentrate to 2/3 water. That will yield 1 cup of juice. And then in the last one, it's going to be 3/8 concentrate to 5/8 water. That will yield 1 cup of juice. So the last one's kind of tricky, but for mix A, hopefully you can see the pattern there. To finish out mixes B, C, and D. And so that finishes us up for this particular section for 1.2, mixing juice, which talks about comparing ratios.